we're going to write the equation of the sinusoidal, not cosinusoidal, if that's even a word, function, represented with each of these situations, and you can ignore the horizontal shift. That would be the c value that, again, is not in this class. So y equals a, that's amplitude, sine, not b. I was about to just write ab, just writing the alphabet here. A times sine of bx plus d. There we go. And let's do it. The tide comes in and out over a period of 12 hours. Now, actually, they just said period is 12 hours. So as we write our final answer, which will be in red, y equals a sine bx plus d. I didn't put a plus because it might be a negative, just saying. As we do that, we're going to come over here and we're going to talk about what B is, and they already told you it was 12 hours. Now, we're not going to consistently find A first, then B, then D, or B, then A, then D. We're just going to find whatever they throw at us. I think the first sentence does give some really valuable information away, though. So 12B equals 2 pi. We'll divide by 12. And B equals pi over 6. Okay, good to know. We now know what B is. Okay, the maximum depth of the water is 1.8 meters and the minimum depth is 0.4. If you want to visualize this, you can draw it. You could go, let's see, the highest we ever get is 1.8 meters. The decimal just sort of floats there. The lowest is 0.4. So what I need to know is what's exactly in the middle, and this is where you average them. So what's halfway in between 0.8 and 0.4? Well, let's do a little bit of work here. So 0.8 plus 0.4, we're going to divide it by 2. Let's do it a little bit differently. We'll divide 1.8 by 2. Let's divide 0.4 by 2. And that's going to give us 1.1. So 1.1 is the middle. This is the midline. So right here, here's your midline, also known as the vertical shift. So we're going to have 1.1. It was indeed 1.1, which really makes sense. This one wouldn't be negative unless we're below sea level with the tide. That doesn't happen. No, that's not a thing. Not that I've ever experienced. All right, so we also need to know what the amplitude is, and the amplitude is going to be this number right here. So here's your amplitude. Also the same here. Better be the same, otherwise it's not halfway. Simply subtract. That's going to be 0.7. Okay, tide comes in and out over a period of 12 hours. We're also going to ignore, it's not stated in the directions, whether it comes in first or comes out first. Positive 0.7, negative 0.7, not really the issue. We're just going to interpret the numbers they gave us and ballpark. Well, it's not ballpark. It's as exact as we can be without a horizontal shift and without a sign in the front there, other than an understood positive. Okay, a racehorse that is running has an average lung capacity of 50 liters. Okay, the average, that number should jump out at you. We talk about the midline, and we talk about it also being a vertical shift. It's also the average. So like the average depth of the water here is 1.1 meters. The average lung capacity of this horse is 50. It'll go higher, it'll go lower, but the average is 50. The midline is 50. So if you want to draw the little visual thing, you can. You can be like, oh, there's 50 liters, and we're going to go up to 78, and that's the highest it'll go. Now, we don't know the lowest it'll go, but we can already figure out this right here. That's going to be 28, and there's your amplitude. So we have not found the period. But we do know A, and we do know D. So, and again, we don't know this one, but like you can really figure it out pretty easily. Subtract 28 from 50. They don't ask, they don't need to know, but I guess as it breathes out, its lung capacity deflated would be 22 liters. All right, so I looked that information up, by the way. I didn't just make those numbers up. Average lung capacity of a racehorse. Breathes in and out every 3.2 seconds. Okay, so that means 3.2 is the period. So we're going to cross multiply this. So 3.2b equals 2 pi. And so b equals 2 pi over 3.2. Hopefully by this point you've noticed something. And I would like to think it's going to be obvious after we do enough of these. And it's this. You have 2 pi over b equals the period. I think it's worth writing. You could say that 2 pi over b equals period, but when you start manipulating this equation, you multiply by b, divide by period. You could also say 2 pi over the period equals b. Really, you could do the same thing. So it's a little handy. Okay, we're gonna have 2 pi over 3.2, and if you're like, man, that's a little sloppy, I agree. Like, I really don't like it. I don't like the decimal inside the fraction. It's just making me angry. So we're gonna change this a little bit. Let's get rid of the decimal by multiplying by 10. If you're gonna do that in the denominator, you have to do it in the numerator. And we're also going to reduce. So let's reduce, one more step. That is divisible by 4. And that is divisible by 4. Okay, double checking my work. Give me a second. Yep, I'm right. So 5 pi over 8 is my, I almost said my radians. Nope, a period. 5 pi over 8. Is that right? Yeah, okay. All right, a leaf floats on a pond that is 1.2 meters deep. That's the average, that's the midline. It's not stated directly, but that's it. So y equals a sine bx plus d. Bobbing up and down, distance between its highest and lowest is 6 centimeters. Okay, we have an issue here. This is meters, this is centimeters. So I personally think the best thing to do is to go for the smallest unit of measurement. So instead of 12 meters, 1.2 meters, I'm gonna say 120 centimeters. So we're gonna put this whole thing in centimeters. So this is gonna be centimeters here, and everything else is measured in centimeters as well. So even though you're like, hey, I don't see a 120, yeah, you do. 120 centimeters. Okay, so let's draw this little thing. So we have 1.2. And the distance between its highest and lowest depths is 6. Oh, they gave us the amplitude. Well, how convenient. Like, we don't even need to know the other numbers. That's it? Okay. So 6. And we do need to know the period, which they told us. It moves from its maximum to its minimum and back to the maximum every 8 seconds. So 2 pi over b equals the period. We can also do 2 pi over the period equals b, just saying. Very last problem we do like this, and now I'm showing you the shortcut. Sorry. Pi over 4.